Hello and welcome again. Today we look at this multiple choice question from the Caribbean Examinations Council CAPE Exam Specimen Paper 2017. This question says, based on Le Chatelier's principle, which combination of observations is not true? Now, of course, we need to be very careful with these types of questions. The word not. So in other words, one of these four is false. Now the question itself asks for the students to use LCP, Le Chatelier's principle. Today we are going to solve this question, first of all, using what's recommended here in the question, which is Le Chatelier's principle. But then we will explore a completely different way to conceptualize and to understand what is being communicated in this question without the need to apply Le Chatelier's principle. But first, let's apply LCP. And the way students are taught to apply LCP is to think of a reaction such as A plus B giving C. And if this reaction happens to be exothermic, then we would say that heat is a product. If a reaction is endothermic, then we can think of it as A plus B plus heat here on the reactant side to give C, this one, endothermic reaction. So in the endothermic reaction, heat is treated as a reactant, and in the exothermic reaction, heat is treated as a product. So with that behind us, let's look at the question now. A says, if a reaction is endothermic, which is the one in black here, then a temperature decrease would increase the amount of the reactants. And in applying Le Chatelier's principle, we are encouraged to think of heat as being the same as temperature. Of course, temperature is a measure of the average kinetic energy of molecules, and heat is the absolute energy or enthalpy in the system. And they are very much related. If we apply Le Chatelier's principle to A here, it's an endothermic reaction, which is like this one here. And if we decrease heat by decreasing temperature, then the effect on the reactants. Well, according to Le Chatelier's principle, if we get less of this, or we decrease heat or temperature, then the system will behave to move towards producing or generating more heat or temperature. So if we decrease this, the system will move towards filling it in or opposing what we have done. So we have decreased temperature or lessened heat. The system would be driven towards filling in. So therefore, reactants would increase as the reaction drives in this direction. So we can say that A is correct. Now let's look at B. B is also an endothermic process, but if you notice, temperature change now, it's an increase in temperature, so we're giving more heat on this side here. Temperature and heat being seen as the same thing. And if we give more of this, the system would move to go in this direction and use that up. So therefore, we would have a decrease in reactants and an increase in products, as is suggested there in B. A decrease in reactants and increase in products. Notice we haven't been making any use of Kc, which is not relevant to solving this question, as we will see. So B is also correct. Now let's look at C, which is an exothermic reaction. And an exothermic reaction, heat energy is released. Treating temperature and heat as the same thing, then an increase in temperature would be an increase in heat, and that would drive this reaction this way according to Le Chatelier's principle. So reactance would increase. And that's not what C says. C says reactance will decrease if you increase the temperature in an exothermic reaction. So from the look of that, it seems as though C is our answer. And it's the wrong one. It's the one that's not true. But let's look at D. And D says exothermic reaction again, which is one like this one here in red. We decrease the temperature this time, so we give less heat. The system would be driven forward to generate heat if we do that, opposing whatever we do to it, and the effect on the reactants would be less as we get more products. So D is correct. And now I want to have us approach the answer to C from a different perspective, not using Le Chatelier's principle, and certainly not treating heat and temperature as the same thing. Now, of course, we've already established that the answer is C. So let's look at verifying answer C by doing a reaction profile diagram like this for an exothermic reaction. This is something that students are required to know about in CAPE chemistry, and we learn about it, but somehow we're not connecting it to these problems. And this is where we are going to try to connect this reaction profile diagram to this question. Now, students would know that this profile represents an exothermic reaction. C and D above speak about exothermic reactions. Students would also know that reactants are on this side, products are on this side, and in this exothermic reaction profile, the energy associated with products is a little bit less than the energy associated with reactants. So therefore, if we say that energy of products minus that energy of reactants, then we would get a negative value for that total energy change in going from reactants to products, a negative delta H or enthalpy change. Moving away from that and just looking at this energy barrier that has to be crossed to go from reactants to products, or to reverse and to go from products back to reactants, we realize that there's a difference in size. Going forward, the barrier is smaller than going backward. Now let's try C and see how C works out, if it's going to make sense. If you increase the temperature, then you increase the probability of product particles crossing the barrier, because suddenly now they have more energy to cross this high barrier. Reactants will also cross the barrier a lot more. But which side will get more benefit if we think of it like that? The product side, which had the bigger barrier, would benefit more from the increase in temperature, relatively speaking. And therefore, overall, with the scenario of C, we are likely to get more products crossing over and becoming reactants than we had before when we increase the temperature. And therefore, the reactant side over time should start getting more. So reactants would increase. And in that way, we have proven that C is incorrect. What I would like you to do is to take this reaction profile diagram and to get molecules on either side and to verify that A, B, and D are correct using, remember, the endothermic graph looks like this. And in this way, you would realize that it's possible to conceptualize or to understand the big picture of what's happening without applying Le Chatelier's principle by rote.